Of you. In this video, we are going to learn about the chopper. What is chopper? Chopper is nothing but a DC to DC converter. You mean input is DC, output is a DC. So, input DC source, you will going to apply. The output is a DC type of the motor you will going to consume. So that is about the DC to DC converter. Types of the choppers. Generally, it is three types of the chopper. What are the three types? Step down chopper. Second one is a step up chopper. Then these two combination. Step up and step down. Okay. Step down chopper, another name is called a buck converter. Step up means boost converter. Then buck boost converter. Combination. You see, step down, first character is S, second character is D. So there is a three component or three element S, D, another one more is a L. S for switch, D for diode and L for inductance. These three element is a combination S, D, L. So like the diagram is a simplest method to you can recap. Okay, if you are rotated anti-clockwise, so 3, 1, 2. So 1, 2, 3. Anti-clockwise means 3, 1, 2. So draw the diagram 3. Third one is inductance. Then 1 is a switch. Another one is a diode. So like you will going to draw it. So this is about the boost converter you will going to get. Okay. Then we will going to see what is the buck converter and what is a boost converter. Okay. Then simplest buck converter. What is this one? Power supply. Switch, load. Switch is on means 40 watt means the same 40 watt is a flow to the load. So when you will go to switch is on, the load is getting. When switch is off, the load is not getting the powers. See, when that one, I will going to give the pulse. Okay, the pulse is I will going to on. So once I will going to on, the output is I am getting T on. When I will going to T on the switch, on the switch, output is a V naught is a produce. I naught also produce. Current and voltage in the output is produced. When the switch is off, output is a 0. Current also 0. So this is about the simplest diagram about the conventional step down or buck converter. Here what is a load? R load is used. Then you have detailed diagrams. Buck converter. Switch S, D, L. Okay, there is a two mode of operation. Mode 1 is a switch is closed, diode is not present. Okay, inactive. Mode 2 switch is open, diode is active. Okay, switch is closed, diodes are inactive, leave it. The current is a flow from the source to the load through inductance to the close. In the mode 1 you have look it, when the switch is closed, these two also act as the consumer load, L load and R load. The both also it will going to consume. When the switch is closed, so output voltage is present. What about the inductance? So during the time it will going to, when the switch is closed, it is charging. Charging the inductance is getting the charge. Okay, when the switch is open, the charged energy is okay, through the loop, it is a discharge. Okay, so when the switch is on, inductance is getting the charge. When the switch is off, inductance is a discharge. The inductance value is low or high. If the inductance is high, what about that one? Charging, discharging, charging, discharging. Like it will going to repeat it. If inductance is low, charging, discharging, 0. Charging, discharging, 0. Like about that a discontinuous load current you will going to get. Okay. So this is the equation of that buck converter. V naught average is equal to alpha into Vs. What is alpha? Duty cycle. Duty cycle means alpha is equal to T on divided by T. T on upon T. Or T on divided by T. T on time divided by total time. What is the total time? On time plus off time. On time plus off time. So 1 upon the T is equal to frequency. Okay. So boost converter or step up chopper. What is a step up chopper? output voltage is high compared with the input voltage. Output is you are getting high. How you are getting it? So how you will going to get the output voltage is high means source is a 10 rupees, inductance also 10. So these two they will go to 10 plus 10, 20 is giving. Okay, coming to the mode, simplest method to say mode 1, mode 2. Okay, boy is a stay in hostel. Boy is a stay in hostel. Your sister is a stay in home. Okay, your father is a giving the 10 chocolate means your sister only consuming the 10 chocolate. So here is a boy he is in hostel. Okay, the same 10 chocolate is consumed by the sister. Okay, mode 2 condition, father and sister both are see the boy, the sister is see the brother. Okay, so both are meet the brother in hostel. Okay, in hostel they are meeting on that one. Both the father and the sister both are meet the brother in hostel. So when do they will going to meet? When they are going to leaving at the time, father is giving 10 rupees and the sister also from from her pocket money. Okay, she also giving the 10 rupees. So 10 plus 10, 20 rupees is going to the brother. Okay, so lovable sister, she is giving on that one. So the total money is giving. Okay, though both money is going to that one. Similarly here also same model. So mode 1 condition, switch is closed, inductance is getting the charge. Inductance is getting the charge. What about diode? Diode is open. During the mode 2 condition, switch is open, diode is active. So inductance energy and the source both it is a Vs plus VL. Vs plus VL. VL is nothing but L dot di by dt. So both voltage is supplied to the load. So this is about that one step up chopper. What is the waveform? Mode 1 conditions. Does boy is present in the home? No, boy is not present in the home during the turn on of the switch. Okay, who is present? So only sister is there. What sister is doing? She is taking that she is consumer. So taking for the 10 chocolate from the father. She is alone. It will go to taking the 10 chocolate. Okay, during the mode 2 condition, what about the mode 2 condition? Father and sister both are meeting the boy. Okay, when do they meet on that one? So father is giving the money as well as sister also. Sister is her pocket money from the savings. She is total money is giving. So discharge. At the time output voltage is present, output current is present during the mode 2 conditions. Okay, so this is about the boost converters. So coming to that one, types of the chopper. So types of the chopper, okay, with respect to the output voltage, step up chopper, step down chopper, or the combination of buck boost converters. Okay, direction of the output current and voltage wise, it is classified into the 5 types. Class A, B, C, D, E. A is a 1 quadrant, B also 1 quadrant. C is a 2 quadrant, D also 2 quadrant. Then class E is a 4 quadrant. Class A, what is that one? Class A nothing but a buck converter. Class A nothing but a buck converter. Class B, boost converter. Class C, combination of AB, buck converter and boost converter. Okay. See, we'll see. What is a class E? Class E is a 4 quadrant. Why I want to see this 4 quadrant? Where it is applicable? Electrical vehicle. Your EV vehicle, forward motoring, forward brake, reverse motoring, reverse brake. So like about the 4 operation you will going to do. So this is a quadrant number 1, the number 1, 2, 3, 4. So quadrant number 1 is a class A. What is a class A? Output voltage and output current both are the positive. What is operation? Forward motoring. So due to the both are the positive, that's why forward motoring is take place. It's a source to the load. Source to the load. Power is a flow from source to the load. Motor is operating. Motor is consuming. It will go to working. Then I want to stop forward braking. How to stop? negative the current. Positive the voltage, negative the current. It's a quarter number 2. Forward braking. Forward braking. It is called a boost converter. It is called a boost converter or step up converter. So when the step up converter is activated, when the vehicle is moved from the hills, from the top of the hills to the bottom of the hills, so at that time regenerative braking, the braking, it is a take place. So at the time only it is a take place. Okay, we'll come back to that. This is a place. This is a normal buck converters over, and here is a boost converter, but a small variation. Okay, we'll going to discuss what is a boost converter, small variations. So we already discussed about the boost converter. This is a boost converters. What is that? How the three component is developed? 3, 1, 2. Anti-clockwise is rotated. 3, 1, 2. Who is that supplier? Supplier is a battery source. Who is consumer? Load is a consumer. Okay. Here class B chopper is nothing but a boost converter, you are saying. Here one analogy we will go to discuss. Analogy. Then we will going to see the diagram of the class B chopper. What is analogy? Girl student. Girl student, take it. Before marriage, they are taking the money from the father. They are taking the money from that one expenses purpose or that pocket money, whatever that one you can take it, whatever you can think it in that purpose. Okay, take the money from the father. After marriage, the money is taking from the husband. Okay, so before marriage, who is the supplier? Father. After marriage, who is the supplier? That is husband. That's all. So boost converter, same model. Okay, 3, 1, 2. Who is supplier here? Here is a supplier, is a father, battery. Then after marriage, who is supplier? Husband. Husband means here, what is that one? The husband means here. The husband is nothing but what is that one? Who is supplier? This machine. The machine is supplier. What is a machine? Machine is act as a generator. Machine is act as a generator. Husband. Husband is supplier. So husband is supplier. Okay. So husband is giving the money. You are going to getting the money from the husband. So you are going to saving the money. You are going to save the money in the box. Okay. So this is a differentiations. The same 3, 1, 2. 3, 1, 2. Same it is a quarter number 1. Okay. Here source. What is a source? It's a generator. The machine. The machine is a supplier. The machine is a supplier. So inductance is switch is closed. Inductance is getting the charge. Okay. Mode 2 condition. The switch is open. Okay. Diode is closed. Okay. So supplier plus inductance. Both there is a flow to the box, storage box. Okay. Here is a question. After marriage, you are going to whom you are going to get the money? Husband. When husband is giving the money, does husband is running on that daily routine of the life? Does he is ready to give? No, because he want to take care about the family expenses, children's education, etc. So extra additional money is not ready to give the money to the wife. Then when he is ready to give the money to the wife during the vacation time. Vacation time, his mindset is totally changed. So husband and wife, they are moved into the hills place. So hills place, their environment, locations, they are changed. So this is applicable on that. The system is moved from the hills place, hills, top of the hills to the bottom of the hills. So the system is applicable on the husband is giving the money only on the vacation on the hills place. So when he is moved from the top of the hills to the bottom of the hills, at the time he is going there to the home, so he is giving the money. Similarly, it is applicable to at the time only. So regenerative braking system. So generate the energy, you will going to pass to the battery source, you will going to store it. You will going to store about that one. See, Compared with the buck converter, it is opposite direction. That's why it is about that boost converter. Okay, so let's go to that summary. What is a class A chopper? It's a only one quadrant, that is called the first quadrant. Both V0 and I0 are positive, so it's a forward motoring, or it is called a rectification mode. What is rectification mode? Energy flow from source to the load. It has the two mode of operation. Mode 1, switch is closed, source to the load. Mode 2 condition, what about that one? Switch is off, energy stored in the inductance, it's a discharge. Okay, so discharge slowly, it is a discharge. Slowly discharge. Okay, so what is output voltage across? 0. So this is about the class A chopper. What is a class B chopper? It is also only one quadrant. The quadrant is a second quadrant. Output voltage is a positive, output current is negative. The energy is a flow, output is a energy is a flow from load to the source. Load to the source. So that's why it is a forward regeneration or forward braking or inverting, you can call it about that one. So regenerating means what is that one? It is a energy is a transfer from load to the source. Load to the source. Here we have husband is a load. Husband is a load. That means the system or the machine. The machine is act as a generator. Generator is a source to the battery, storing the battery. That's all. So this is about the class B converters. Class B converters. The next one, class C converter. What is a class C converter? It's a combination of A and B. A for forward motoring, B for forward braking. So this is a diagram for that one class C chopper. It has that 4 mode of operation. As well for that mode 1, what is that one? Buck converter. Mode 2, boost converter. Boost converter means regenerative braking. Regenerative braking means what is that one source? The source is a husband. Husband is a supplier. Husband is a supplier. And the consumer is a same. Battery will going to store in that one. So that one. So who is first one? Rectifications. Rectification consists of these two mode classified. See, source flow to that load and load through the inductance. Inductance it is getting the charge. So inductance is getting the charge. A to B. Inductance is getting the charge. Okay, output is getting that one. Yes, output is V0 is a produce. Okay, then mode 2 condition. The switch is open. Then here across the diode is through that one. Here is a form the closed circuit. The stored energy inductance, it's a discharge. Stored energy in the inductance is a discharging B to C. What about output voltage? Closed circuit, so output voltage is 0. Then mode 3 condition. What is a mode 3 condition? Husband. Husband is giving the energy to what is it one? Wife. So regenerative braking. So here source is a husband. I mean load is a source. Load is act as the source. Okay, generator. It is act as a generator. So during the time it's a charging. Charging you have see plus with respect to minus. Here this side is a plus with respect to minus. It's opposite direction. So it will going to get the charge. Get the charge. What about the one closed circuits? So output is voltage as it is 0. Okay, as it is 0. Closed circuits. So across that one closed one, so 0. Then after D to E, the stored energy inductance, it is a discharge. Same about that one stored energy discharge via this is a root. It is a discharged D to E. D to E. So output voltage is started. Here is across, it is a take place. So output voltage is now start. Start to it will going to trigger. So this is about the class C type of the chopper. So summary of the tables. So mode 1 and mode 2 forward motoring, rectification, and then these two mode is a inversion, forward braking. So here is a L is charge, discharge. When the switch is closed, L is charge and then discharge. L is charge in opposite direction and L is discharge. So that's all about that class C chopper.